Okay, I'm back with another video on basic algebra. Today we're going to look at how to find the LCM, or the least common multiple. So let's start off to get an idea of what this is. Let's look at multiples of 3. The multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. In other words, you multiply the number by 1, by 2, by 3, by 4 consecutively. And of course you're going to have an infinite number of multiples of 3. Below I have the multiples of 7. 7, 14, 21, 28, and so on. So when we talk about the least common multiple, we usually refer to the least common multiple of 2 or more numbers, or it could be algebraic expressions. So if you have numbers, you can make out the list like I did here, and then just find the smallest number that's common to both. That's why they call it a common multiple. In this case, we're looking for the smallest. So notice that 21 is a multiple of 3, and 21 is a multiple of 7. And that's the smallest number. That's a multiple of both 3 and 7. Now, there's infinitely many numbers that are common multiples of 3 and 7. But if we're looking for the least common multiple, we want the smallest. So in this case, it's 21. Notice that if I continue the list of multiples of 3, I get to 42 over here, and 42 is also in the list for the multiples of 7. But we want the smallest, so this would be 21. So when we talk about the least common multiple of 2 or more numbers, we're simply talking about the smallest positive number that's a multiple of both. Or another way to say it is those particular numbers have to divide. They both have to divide the lowest common or the least common multiple. Okay, so you could do this with a list like this. It's not very convenient though to do that if you have algebraic expressions. Okay, so you have to factor in order to find the least common multiple. Now if you're dealing with fractions, the least common multiple is basically going to be your LCD, or the lowest common denominator. So let's look at what we would do to find the least common multiple of some numbers. So let's suppose we say find the least common multiple of the numbers 15, 18, and 98. Leave your answer in factored form. What we would do is we would factor each of these. So we would take basically we would do this. We would take 15 to start off with, and then we would divide it by the smallest prime that would divide it. So we always start with 2. That's the smallest prime. 2 doesn't divide 15. Then we go to the next one. The next prime would be 3. 3 into 15 is 5. And then we continue the process until we get 1. Okay, the smallest prime that will divide 5 is 5. So once we get to 1, we stop. So the product of these factors in should be 15. So I put 15 as in terms of product of primes, 3 times 5. So to prime factor a number means to write it as the product of primes, or the product of powers of primes. Okay, so for example, in the next one, 18, the smallest prime that divides 18 is 2. So I put a 2 out here, and then 2 into 18 is 9. And then I continue. The smallest prime that divides into 9 is 3. 2 doesn't go into it evenly. So 3 into 9 is 3. Smallest prime into 3 is, of course, 3. So I get 1. So I stop when I get a 1 here. Then I multiply this out. 2 times 3 times 3 should be 18. So the 3 times 3, I write it as 3 squared. Okay, so this will be 2 times 3 squared. In the same way with 98, if I wanted to prime factor it, again, I would divide the smallest prime that divides it is 2. Okay, 2 into 98, 49. Smallest prime that divides 49 is 7. 7 into 49 is 7. And the smallest prime that divides 7 is 7. Okay, so I stop there. So the product of 2, 7, and 7 is the prime factorization. I write the 7 times 7 is 7 squared. So there you have it. Okay. So the procedure for finding the LCM of 2 or more numbers is basically a prime factor each of the numbers. And then for your LCM, here's the way it works. LCM, or least common multiple, you simply write down all the different factors or bases that appear without repeating. Okay, so I look at 15, the product of 3 and 5, so I have to write a 3 and a 5. 3 times 5. Okay, then I go to the next factorization. The bases are 2 and 3. Okay, so I put a 2. I already have a 3, so I don't have to repeat that. Then I go to the next one. And the next one has factors of 2 and 7 squared. The 2 I already have it, so I don't have to repeat it. And then I have the 7. Okay. So again, you prime factor each number. And then for the LCM, it's going to consist of all the different bases that appear in those factorizations without repeating. Okay. Then you have to decide on the power. So you simply look at all the bases that have, all the factors that have a base of 3, and there's only 2, and you take the largest power that goes into any one of these. So this has a 3 squared, so that's what you put here, 3 squared. Okay, then 5 to the first, you look at all the different factorizations, and there's only one that has a factor of 5, so that says 5 to the first. The same thing with 2. There's only 2 factorizations that have the prime number 2, and each of them have to power of 1, so always take the largest power. Well, it's 1. And then the 7, there's only one factorization that has a 7 as a base, and the power on that one is 2. You always have to take the largest. Okay. You multiply these numbers out. So this is 3 squared, and on this one it says leave the answer in factored form, so this would be your answer. 3 squared times 5 times 2 times 7 squared. But if you multiplied it out, you would get this answer that I have over here. So notice it's 3 squared times 5 times 2 times 7 squared. So if you multiply these numbers out, you'll get 4,410. 4,410. And to double check, you could divide 15 into 4,410, and it'll divide with the remainder of 0. 18 will divide it with the remainder of 0, and 98 will divide it. That's one way you can check that you do have the correct answer. Okay. Now sometimes if your numbers are small, you can kind of figure out what the LCM is without having to do the factorization. But when you're dealing with algebraic expressions, it's not always that easy. Okay, so in the next example, let me clear this. Okay, so in the next example, I have 3 trinomials, and I want to find the LCM, or the least common multiple. Well, the procedure again is to factor. So we had several lessons dealing with factorization. So in the first one, x squared minus 2x minus 15, using the techniques we covered before, that factors into x minus 5 and x plus 3. The next trinomial is x squared minus 10x plus 25. If you factor that out, again, using the method of trinomials, you get x minus 5 times x minus 5. And you can write that as x minus 5 squared. X squared plus x minus 6 is also a trinomial. It factors into x plus 3 and x minus 2. So then following the procedure that I just outlined for numbers, it's the same thing. Your LCM is going to have a factor of x minus 5. It'll have a factor of x plus 3. It'll have a factor of x minus 2. And the power on each of those factors will be the largest power that appears in any of the factorizations. Well, all of them have powers of 1 except the x minus 5. So that should be a power of 2. So for your LCM, you're going to have x minus 5 quantity squared times x plus 3 times x minus 2. That's your LCM. Now, if these expressions that I have here were denominators of a fraction, then this would be called your LCD, or the lowest common denominator. Okay. In the next lesson, we'll be dealing with addition, subtraction of rational expressions. So in order to add or subtract rational expressions, you have to find the lowest common multiple, which in that particular case is going to be the LCD, or lowest common denominator. Okay, so we'll continue here with the next lesson. So again, please subscribe to the channel, and we'll see you in the next video.